Good morning. It is Monday, December 1st, and this is e-learning day because of all the snow and ice. You might expect, I don't know, I'm kind of thinking that might happen again tomorrow because we're supposed to get a little more snow tonight. So I wouldn't be surprised, but I plan on being here. But just in case, just don't say I didn't warn you. Plus, then remember, Wednesday, Thursday, I'll be gone for my cataract surgery. So let's get going. I sent you this on the email, or I posted a copy of this on Google Classroom, so you should have it available to you. And so here we go. This is chemical reaction types practice problems. We did some of these last week. So let's see what you can remember. I really wish that 2 was not there. Let me black out that 2. I'm trying to black out the 2. We're pretending that 2 isn't there. So it's just hydrogen plus oxygen. And what do you get when you mix hydrogen plus oxygen? Well, we should get water. And what kind of reaction is this? This is a synthesis. Remember the types of reactions. We had, that was synthesis. We have this one as decomposition. Remember there were 3 special decompositions, the one with chlorates, the one with carbonates, and the one with hydroxides. Then you might have A plus BX. We called that single replacement. Remember, you got an element and a compound, and the element trades places with the element in the compound. Double replacement, AX, BY, and A and B are trading partners. That is double replacement. We had the acid base. And finally, we did combustion. And the products were always CO2 and H2O, always. And this was combustion. So there you go. There's a quick reminder of what the different types of reactions were. So here we got just the one element, or one compound, calcium carbonate, and it has no other reactant. Remember, the reactants are on the left side of the arrow. Maybe we haven't talked about that. I don't remember. Calcium carbonate, but that's a special decomposition, and metallic carbonates, calcium's a metal, will make metallic oxides, so calcium oxide and carbon dioxide. That's what you make. Okay, and that is decomposition. Here we've got an element and a compound, and the element is a metal, so we're replacing the metal, so it would be zinc sulfate and copper. Single replacement. The next one we have silver nitrate plus sodium chloride, so we're going to make silver chloride and sodium nitrate. This is easy because the silver is +1 and the chloride is -1 and the sodium is +1 and the nitrate is -1, so we don't have to worry about any subscripts or anything. Same thing up here. This was copper was +2, and here, or the zinc was +2, the copper is +2, the sulfate's -2, -2, so everything's balancing out well enough. All right, CH4 plus O2, this looks like combustion. So the products are always And here's another one, magnesium hydroxide. That's also that's a special decomp. Maybe make magnesium oxide and water. I'm sorry, this was not decomposition. This was combustion. My mistake. This is double replacement. Single replacement. There, now we're caught up. All right, so the next page. There's 1, 2, 3, 4 more. Why don't you pause the video here, see if you can do those 4, and then I'll come back and show you my answers. So go ahead and pause. You can do it. You can pause. Hit pause. Well, hopefully you hit pause, and now we are back live. So potassium chlorate, that is again, there's only the one reactant, so it's got to be decomposition. And this was a special one, KCl plus O2. Metallic chlorates. Right, turn into metallic chlorides. And oxygen. This one here, now the tricky part on this one is iron can be either +2 or +3. Hopefully you didn't put it like this. Hopefully you did not do this. Hopefully you did not do that. Hopefully you did not do this. Hopefully you didn't. What we should have done, if it's iron making a +2, then it would be FeCl2 plus H2. It has to be H2 because it's hydrogen, it's diatomic. Or you could have done FeCl3 plus H2. This would be iron 2, this would be iron 3. All right, now next we got the lead nitrate and the potassium iodide. You should have seen that was a single replacement. This is a double replacement. So the lead and the potassium are going to trade places. Notice, though, that the lead is a +2, nitrate is -1, potassium is +1, iodine is -1. So PB will need 2 I's, right, because it's +2, and each I is -1, right? So we got to do that. And KNO3. Remember, we haven't learned to balance anything yet, so don't worry about balancing. And finally, looks like a synthesis. Making aluminum oxide. Right, and we know aluminum is a +3 and oxygen is a -2. Oops. Oxygen is a -2. So the 2 is going to go here, the 3 is going to go there. Al2O3 is what we get. So hopefully you did okay with that. Send me a little comment or something when you've got this done so that I know you did it. And that will count as your attendance for today. So you must respond in some way to let me know that you did this. Probably on Google Classroom would be your best bet. If you can't do that, send me an email. But my email box is going to get full. So probably better off to just mark it done on Google Classroom. And hopefully I'll see you tomorrow, but you never know.